My name is Paul Roundtree, and in this video I'm going to describe how to set up the toolpaths to test out the lathe CNC attachment. The inspiration for this comes from a work from Larry Hancock's turntreasures.com website, where he uses some of his experience with gavels to demonstrate lathe techniques. And so this is the kind of shape that I'm going to be working on, although not as fancy as the ones that Larry has put together. The way that I'm going to do this is, instead of using the wrapped technique that most vectoric programs or people tend to use, I'm going to think about this instead of designing a vector that looks exactly like the side profile that I'm going to be using, and then I'm going to project that onto a vector to make it the tool move in Z according to the line that I've just drawn. So here's what I'm using as the starting bits for making this shape. This is all drawn in the vectoric codes. I used Aspire, but it works exactly the same way in VCarve Pro, anything up after version 7. So I've used ellipses to define the hammering surfaces. I've got a barrel shape here, some semicircular bumps, plus I've added some posts left and right. That's what's actually going to hold this piece into the turning stalk, so that's the rotation axis. I've set up the job so that the vectors here are symmetric about y is equal to 0, and the thickness of the material is a total of the radius of the piece that's sitting on the machine. So that's 1.6 inches in this particular case. The chunk of wood is also 10 inches long, so that's how I've set up the project here. Once I've got all of these vectors laid out, and I think that this is roughly the way I want to shape it, I use the scissors tool within Aspire or VCP, and I cut away the parts of the design that I don't want to leave me just with the shapes that I do want to keep to using. And so now when I do all of that, what I'm left with is a shape like this. And the way this is going to work is that this shape shows the Z of the design that I want to cut out as I move the cutting tool along the x-axis of the machine. So the x-axis is just this line going from left to right here. The profile is this thing. So if I select the profile, you can see in the bottom right corner the height of this is 1.35 inches. That's the distance from this line here, which I've just drawn to show where the surface of the material is, into the deepest point, which is back here, 1.35 inches. To do the work of projecting this onto my vector, I select first the profile, then the rail, and then I run the gadget called FlutePlus. And with FlutePlus, you select a tool that's going to use for the cutting. In this case, it's going to be a 3/8 of an inch square end mill. I'm going to build a toolpath called gavel. These are the parameters I've used to set this up. It works very well under these conditions. And this defines how the shape of the gavel is going to be run. It's going to start at 0, which is the surface of the material. The start depth is 0. The flute depth is going to be 1.35. That's what we found was the actual height of the profile vector that I'm using. And the profile steps of 10,000 just means that I'm taking a very fine step from left to right to try and capture the shape of the profile as accurately as possible. 10,000 means that I've got a step every thousandth of an inch, which is far more than you really need. You could probably get by with 2,000 and it would still look just about the same. So all the parameters set up the way I want them, and so now I say go. And what it's calculated is how to impose this Z shape along this vector moving along X. And if I move over to the 3D view, you can see my material, which I've just modeled as a 0.1 inch thick slab of wood, and the blue line is showing the toolpath. If I preview that, one of the things that FlutePlus does is that it interprets the shape that you've got in the profile vector as the material that's to be left behind. And so it uses the shape of the tool to make sure that you don't intrude and cut away from the wood that you want left behind. So in this case, you can see the barrel type structure with these semicircles and the hammer surfaces all cutting into it. These are the posts that are going to hold the wood onto the tail and the headstock. This edge here is just drawn to make sure that my cutting tool and the collet nut don't hit the surface as I go deeply into the wood. So it's just a convenience. It could have been steeper, but this is what the way I drew it. And so this is what I'm hoping to see at the end of the whole operation. Now the lathe accessory that I've built can turn up to several hundred rotations per minute, And with a piece of wood that's 3 inches across, that means that the surface of the material is turning at about 5,000 inches per minute, which is very, very fast. And so obviously I can't dig into the material to full depth in a single pass. Something would have to break. It would probably be my tool, router, and my CNC machine. So instead of doing it all in one pass, we have to do roughing passes. And that's also possible with the FlutePlus gadget. If we go back up, we've still got those vectors selected, so I don't have to change anything. I'm going to the FlutePlus gadget, and I'm just going to check this box, and it makes the roughing passes. The tool that I'm using has a step down of 30 thousandths of an inch, or about 3/4 of a millimeter. With this distance, now I'm going to be able to casually and calmly carve out that wood without causing damage to hopefully anything involved. Everything else stays the same. I say make it, and it quickly calculates the pattern. And now when we swing over to the view, you can see that instead of a single pass, we've now got this layered structure where it's taking multiple passes going from left to right in order to carve its way down. The way that the FlutePlus calculates the roughing passes is to minimize the Z motion. And so these passes are flat across the top until you're about to bump into something, then it goes above it and continues on its way. This is not the most efficient way perhaps of designing this toolpath, because you can see that for many of these paths it will cut deeply here, but in this section it's already gone to the full depth that it can possibly go to. So you're wasting a lot of time moving over material that you're no longer cutting. A better way of doing this would be to divide it up into a left region, a right region, and the center bit, and to toolpath those separately, and I'm sure that would bring the toolpathing or the cutting time down. Right now it's about 25 minutes. It could probably get down to about 10 minutes to do this. So once you've got the toolpath set out, you like the look of it, you save this to the G-code file, and then you head on over to the CNC machine to see what you can do.